All right, so welcome back, guys. So this lecture we will be solving one of the examples 2.1 given in the book. So the example says find the angle between two forces of equal magnitude when the magnitude of the resultant is also equals to the magnitude of either of the two forces. And we can represent this problem using the vector diagrams as such. So we have the force F1 completely lying along the x-axis, and then we have the force F2 that is making some angle theta with the x-axis, and that together F1 and F2 make up this resultant force, which I have named R. So the goal that we have here is to find the angle theta. Before we really get solving it, it says that the resultant is also the magnitude of the resultant is equal to the magnitude of either the forces. And since the two forces have equal magnitude, we can actually say that F1 is equals to F2 to R. In terms of magnitude, after I've written magnitude, the magnitude are actually all the same. Anyways, our goal is actually to find the angle theta. So the theta is the unknown here. So to actually solve it, what we first do is that we find the components Rx and Ry, the two components of the resultant force first of all. So the resultant force that we have is R, and obviously it has two components, Rx as well as Ry. Rx is actually given as, obviously, since it is the x component, so it is going to be the sum of the x components of the two forces that it is made up of. So it is made up of F1 and F2. So Rx is going to be the sum of F1x plus F2x. Only the x component of the two forces. That is going to be, the sum is going to be equals to the Rx. Now, since F1 is lying completely in the x-axis, so you see this is the x-axis and F1 is lying completely on it. F1 is actually making no angle with the x-axis itself. So what we write at, and if you remember that in the previous video we actually talked about that the horizontal projection or the projection along the x-axis is always taken with respect to cos theta. So we say that the F1x is actually equals to F1 cos 0, since it is making no angle with the x-axis. Actually, you can see here as well, along the x-axis F1 is making no angle. F2 is actually making an angle theta, which is still unknown, so we'll write it as it is, F2 cos theta, where theta is the, let's clean this up. So we have F2 cos theta, and Rx is equals to F1 cos 0 plus F2 cos theta. Now we know that cos 0 is actually equals to 1. So this is simply F1 plus F2 cos theta. And we already know that F1 and F2 are all equal. So what we say is that Rx is simply equals to, let's call this all of these equals to F, since these are all equal. So we can use a dummy variable F plus F cos theta. This is the x component actually for the resultant force. Now we go on to write the y component. So similar to as how the x component of the resultant was equals to the sum of the x component of the forces, the y component is actually also going to be the sum of the y component of the two. Anyway, so we have F1y plus F2y. But notice that when we wrote F1, it is lying completely on the x-axis. It actually has no projection along the y-axis. It actually has no vertical component. So there won't be any contribution from the F1y part, since it has no uh, projection or the component along the y-axis. But we can actually write it as f1, and we already know y component is written as sine. This is sine 0 plus f2 sine theta. Theta is again the same unknown that we mean to find. We already know sine 0 is 0. So this actually validates our point that since uh, f1 has no component along the x-axis, so it is going to be 0. All right, so the only thing we are left with is ry equals to f2, or we can just call it f is equal f sine theta. Now that we have actually obtained the two components, what we can do is that we can find the magnitude, use the expression for the magnitude of the total resultant vector, which says that r square is equals to rx squared is big. When I'm writing square, I don't really need the square root. Since we're just writing the square here, we're not taking the square root right now. Rx squared plus ry squared. Anyways, we'll just plug in the values. Rx was found to be f plus f cos theta, whereas ry was found to be f sine theta squares. And since we already talked about it, that the magnitude of r was simply same as the f1 and f2, which we had called as f, we write it as f squared. We open the squared formula here, which results in f squared is equals to f squared plus f squared cos squared theta plus 2f squared cos theta, plus we take the square of this term as well, which is f squared sine squared theta. There is a lot of simplification to be made here, so we can easily see that this f square cancels out with this f square, and also uh, f squared cos squared theta and f squared sine squared theta, this can be simplified by f squared cos squared theta plus squared plus the remaining part, which is 2f squared cos theta. Now this is very well-known simplification. It goes out to 1. So what we are left with is f squared plus 2f squared cos theta equals to 0. We can take common here, f squared is taken as, we're left with 1 plus 2 cos theta equals to 0. Now whenever we have this kind of situation, so this whole equation implies that this is equals to 0. Now either this term is 0, since it is multiplied with this and it is giving a 0, or this whole term is 0. In such a case, obviously f squared can't be 0 because the force is not 0. We do know there is some non-zero force, which is f1 or f2 or the resultant. This is not 0. F is not equals to 0. So this term must be 0. So 1 plus 2 cos theta equals 0. We have 2 cos theta equals to minus 1, and cos theta equals to minus 1 over 2, which is minus 0.5. Now we already know how to solve this. We say cos theta equals to negative 0.5, and this implies that theta equals to cos inverse 0.5 negative. Whenever we say cos inverse 0.5, what we mean to say is what angle would give cos as 0.5. We already know that it is going to be 60. Normally, you see that negative here, my bad. So at 60 degrees, actually, cos is 0.5, but we are looking for negative 0.5, which exists something like here, negative 0. And this angle is not 60, it is actually twice that, which is 120 degrees. So the answer is actually theta equals 120 degrees. This is actually important in a sense where I've actually done this thing of finding out what angle corresponds to negative 0.5, because you already know cos is a projection along x-axis, or this projection along x-axis. This gives 0.5 because it is positive here, but if you want to have negative 0.5, that exists on the other side of the axis here. And here the angle is not 60, it is instead 120 degrees. So that's how actually we find out that the theta is 120. So this angle is actually 120 degrees. Anyway, so this was the solution. I hope it was clear enough. We started off with first of all identifying that since the question says that the all forces F1 and F2 are equal and their magnitude to the resultant is also equal, we put it equals to a single force, and the unknown is theta. We first of all write the x component of the forces. Since F1 makes no angle with the axis, it is 0. So it turns out to be, we get this. As far as the y component of Fy is concerned, there is no y component. So it is straight on 0. The only component that remains is F2 component, F2y component. We just use the Pythagoras theorem that we have already discussed about, which relates the resultant to the two components, the rectangular components. We just simplify it, and at the end we are left with theta equals to 120. All right, thank you so much.